So we discussed about what is 624 earlier in the class, but I just want to quickly give you a revision. We have sites in blue, meaning they are IPv6 sites. And in the middle, we got an internet which do not know anything about IPv6, or there is no support for IPv6 to the end customer. There is no support for IPv6. There is no support for IPv6. There is only IPv4. But you want here IPv6. What is the possibility? How can you achieve this? For that, we should know the public IP address that ISP gives you. Let us say ISP gives you 1.1.1.1 in site 1. In site 2, somewhere remote, they're giving you 7.7.7.7. This is your public IP address on this edge router. S1, S2. All that we need to do is we need to take this 32-bit address and embed it in the second and third hexadate of your IPv6 address. I repeat. When you plan like the 624, you're going to have a tunnel which can transport IPv6 traffic. And this tunnel is not a fixed tunnel, it is a dynamic tunnel. Based on the destination, IPv6, based on the IPv6 destination, the IPv4 destination is going to be determined. How? I'll show you. Let's say you have another site. And whose IP address is 2.2.2.2. Now, site 3's IPv6 address, where I ping from this computer, which is already in IPv6, when I ping site 3's IPv6 address, the tunnel will be established between these two. After I finish pinging, after I finish communication between site 1 and site 2, the tunnel will get removed. And when I ping someone in site 2, the tunnel will be established with this address 7777, and the tunnel will be able to transport the IPv6 packet. How this is possible? It's only possible when you design, when you plan your IPv6 address by including the IPv4 edge address. For example, on site 1, I'll say 2001 and I'll embed this address here. One hexadate is 16-bit. This is how many bit? 32-bit. So I need 2 hexadate. I embed the IPv4 address inside this IPv6. And now, please mute, someone is typing.
Oh, sorry.
For department 1, if I need a subnet, I'll just say 0001. See, subnetting is very easy. And for department 2, same thing, colon 0002, and goes on. For subnetting, you have one full hexadecimal, 16-bit. I told you out of 128-bit, 64-bit is network. So the last 12-bit, sorry, 16-bit, you can use for subnetting. This 16 plus 16, 32-bit, you're going to have this IP address, 1.1 and 1.1. But you need to convert it into hexa and write it here. I'm just giving you an example. Likewise, here all address will start with 2000, but here you will embed 7, 7, 7, 7, and then if you want subnets, and then 64. Here you will embed 2222. I'm going to do and show you this. First, let us see how to convert that IP address into hexa. I want to convert this IP address 1.1.1.1 into hexa. How will you convert? 1.1.1.1. If I write in 32-bit, it will be like this. Do you all agree with this? This is what this. Now, we learned that 4 binary bit is 1 hexabit. So this is 0, and this is 1, and this is 0. This is 1, 0, 1, 0, 1. That's all. I have embedded. So in this office, this portion will be same for all departments. Only the subnetting side will vary for each department. Now let's see how to embed that 7. 7.7.7.7. 0, 0, 0, 0, 0, 1, 1, 1. This is 7. Dot 0, 0, 0, 0, 0, 1, 1, 1. 0, 0, 0, 0, 0, 1, 1, 1. This is 7. And you all will agree with me. Now, 2000 colon 0, 7, 0, 7 colon 0, 7, 0, 7 colon. If you want subnets, you can do subnetting /60. That's it. Likewise, you will embed 2 also.
Sir, I have a doubt. The last subnet after colon, can we keep any number like 1,
Your
2,
wish.
like for example the range?
Your wish.
My wish, right?
You have 16-bit. If you want to keep your birth year of your birth, you can give.
Okay.
19.
And like when we configure an interface, is it like supposed to be point to point, or like can we give any number? Like for example, if I give 5, can I give 15 like that?
I'm not understanding your.
I mean other interface. No. My question is, see, for example,
Yeah, the other side doesn't matter. You have 64 interface bits.
Okay.
We are not doing that stingy subnetting. In IPv4, we used to do stingy subnetting /30, /48, sorry, /28, you know, that subnetting we don't do here. So you have free to use any big numbers. But if it is going beyond 9, make sure you use ABCD alphabets. Okay, so now let us plan something and do. So each site 3 subnets, 2 departments, department 1 and department 2, and we also need an IP address for the tunnel. On all the departments, we are going to have those 3 subnets. And let's say the public IP address on R1 is 114. And here, let's say 124. And in here, 134. Now, first of all, let us have reachability between these 3 routers using a routing protocol. I'm going to use a routing protocol which is known to all of us, OSPF. Let us focus on IPv4 reachability first, and then we'll get into IPv6. Actually, IPv6, sorry, loopback is not needed here. Better not to have unnecessarily. We don't want that for here in this for the scenario. 114.114.1 IPOSPF. Or I can also have a default route. Let me have a default route. That's it. This goes on router 1. Oh, I got a switch. The image is switch, sorry. Router 1 is good. And router 2. So on router 2, this address is going to be 124. Next, this is going to be 3 here. And the middle one, Okay. I'm expecting reachability from R1 to the other edge routers, ping 124.124.124.2. Because we got a default route, this ping should work. We got default route, this ping should work. If it's not pinging, then there's some mistake I have done. We'll check. Show IP interface brave. Ah, this is the mistake. No shit. Again, same mistake. Okay. So now we should have 124 or 124 or 124.2 reachability now, as well as 134. Ping 134 or 134 or 134.4. No, 3. Yeah. So we got the reachability. See, in IPv6, you don't lose this type of packets we saw. Anyway, this is IPv4. It has to kickstart the ARP and get the response back and then ping. That's why you lose packets. Now, I need to embed this address in all the IPv6 address of this of the site. For that, I need to convert this into hexa first. 114, how will you convert? 114.114.114.114. Who wants to give me an answer? 114. 64 plus 32 is 96. So 114 minus 96. There you have 14. Here you got 4. You got 18. So you want to on these bits?
7 bits
Okay.
on.
So you got 96 plus 7, which will be 33, 103 only you got. But you need 114. What will happen if I on this bit and put this as 0? Then it will be 96 plus 16. Am I right? It will be 12, 2, 1, 9, 10, 11. 1, 1, 2. Close. So we need this bit, this bit, this bit. And then this one. This is 114. Do you all agree? Or am I making mistake? Am I wrong anywhere? Am I right or wrong? Bala, how about
Looks
you?
good, sir.
Do you agree with this? 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4 is 16, plus 32, 2 to the power of 5, 2 to the power of 6 is 64. 64 plus 32 plus 16 is 112, plus 2.
Yeah.
Sorry,
I
Sam,
think
what
we're
did you say?
missing 1, right?
Yeah.
Are we missing one? Because we're trying to make 114 the equivalent of to the
Okay,
power.
1 and
Oh
4
wait,
is right,
actually no,
right?
it's right.
So this is
Sorry,
the one.
my bad.
0111 0010.
Yeah.
So dot, again you repeat the same thing. Sorry. So divide, cut this off in 4 so that you can write hexa. So if you will write this one, what you will write, you will say 7, this one 2, 72, 72 colon 72, 72. That's all. This is the hexa equivalent of this IP. Okay, so I'm going to go there to the board and I'm going to write this. 2000 I would like to use, let's say 2005 or 2024. What's wrong in that? Colon 72, 72 colon 72, 72 slash 48. So for only 48 bit without subnetting, I'm not doing subnetting. I'm just embedding that IPv4 address inside IPv6 address for site 1. Now let us do like that for site 2 and site 3. You convert and tell me. You convert and tell me. So in the previous one, the last one
Yeah,
is
sure.
not
Yeah, I was wondering
114. The
about that
last one
actually.
is simply 1, isn't it? You see, last one is X. X means router number 1. Dot 1. So this will be 01.
0001 last one only.
7201.
Yeah.
Yeah. Okay, so let me correct it there. That 0 has got value. You must put that 0. Okay, now, who wants to say for 124? Mm-hmm.
Yeah, 124
Mm-hmm.
0 111 and 111
Okay, so this is
0.
64 plus 32 plus 16. Okay, in another word, if I need to say 120,
Plus
127 minus 1. Oh, no, this is wrong. This is wrong. This is wrong.
124.
We are close. See,
So 64 plus 32 plus 16 plus 8
plus 8
plus
plus
4.
4, correct. Then why you didn't put 0 here?
Yeah.
Here also it should be 0, no? 2 zeros, no? Okay, then correct, then correct. Okay,
Yeah.
so
Hmm.
this is 124. Again,
Same only.
and then 000010. So if I need to convert this, this will be 7, and this will be 8 plus 4, 12. 12 is C, am I right? 7C, again
Yeah.
7C,
12 is C only.
colon,
APC.
7C02. Is this right? Sam, is this right?
Looks like it's our 7C.
See, this is 7,
2.
no? And this is 12. 12 is C. Again, 7, this is C. Again, this is 7 and this is C. And then this is 0 and 2. Okay, so that's right. 7C, 7C. But am I right or not? Okay, so let me edit this.
Yes, sir.
7C, 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 02. This is what the subnet, the networks of IPv6 in this site. 2. Okay, Sam, it's your turn. 134.
It's
Okay, wait.
10000
Okay, 128 plus
110.
6 you want to say, right? 10000110. Is this right?
Yes, sir.
Wonderful. Excellent.
Right. Yes, sir.
And then yeah. So this is 8. This is 3. No. What is this? 6. Sam, am I doing any mistake? This is no.
I still
You
don't.
just see this 4 number. What is the value now?
I'm not too
Don't
sure
see the
how to
other
add
bits.
these up, sir, to
What is
be
the value?
honest.
If it is 1000, what is the value? 8, no? Hello? Only 4 bit I have. 2 to the power of 0, 2 to the power.
128.
Tell me. What is the value? 8, no?
Oh,
Now again,
right.
see only the 4 bit.
8.
What is the value?
8.
Yeah. This one again,
6.
8. This one again.
6.
No. Wait a minute. This is
8.
this. This is this. This is this. And this one is 3. 0, 3. Okay. 86, 86, 86, 03.
3.
Yeah.
Yeah, I think I need to watch your
But you are
introduction to
good. You are good.
IPv6 to
You
get it.
remember those things that
I
you
still
learned
don't
long
get how
back.
you add it up.
I
But
can see that.
I'll look into that.
You're good. Yeah. As you said, try to watch once 80. You're welcome.
Will do. Thank you, sir.
Yeah. That's it. So now from here, it is very easy. Let me do. I said I want 2 departments. I'm going to use Lubac interface. Department 1 is Lubac 1. The IP address that I'm going to give is 2024. Wait, let me bring it down here. 2024 colon 7272 colon 7201 colon. Because it's a first department, I'm going to say 0001. The leading 0 has got no value, so I can cut this off. Colon colon, the host portion I would like to give x, which is 1 slash 64. Yeah. And for department 2, colon 7272 colon 7202 Sorry, 01, same subnet. Now the address, IPv4 address embedded should not be changed. Colon, only in this octet you can change. Colon 2, colon 1/64. So this is for another department. So I can have millions of IP address in each department. Millions. Because you got 64 more bits for the host in each department. What do you want? Want that? Thank you. Hmm.
Sir, the doubt is we have IPv4 address
No dual stack.
and we have IPv6
No dual
address,
stack.
like it's like a dual
We are
stack.
not giving IPv6 address or
So
Ethernet 00.
so when we do the
If you give Ethernet 00 also with an IPv6 address, then it is dual stack. Don't use the dual stack in here. This is 64 tunnel. When you have both 4 and 6
okay, sir,
existing on the same process or
can you
same
repeat the
interface.
difference once
If
again, sir,
I
if you
have
don't mind?
IPv6 and IPv4 in OSPF in single process, OSPF version 3 supports that. Or if I have same Ethernet 00, both IPv4 and IPv6 on same interface, then it is dual stack. Here, totally different. IPv6, you are not configuring on the IPv4 interface. And IPv4, you are not configuring on the IPv6 interface. This is totally different. For more clarification, you should ask question. What happened? Silent. You see, this is also a subnet,
Yeah, yeah.
0th subnet. You see, I did not use the 4th hexadate, but it is 0 there. /64 I have given. So the tunnel also is subnetted network only. Now, similar to this, we are having in these sites. In site 3, this portion is 86, 86, colon, 86, 03. Likewise, here. That's it. Likewise on the other department, sorry, other site. Okay, now planning is done. Execution is what left. I'm going to do it now. So to simulate two sites, I have loopbacks, interface loopback 1, IPv6 address is 2000, 2024, colon 72, 72, 72, 01. :1 ::1 is the host portion /64. Likewise, interface loopback 2, that is for the department 2, just one number I'm going to change in the subnet portion. That's it. And now on the loopback, on the ether, on the tunnel interface, we don't do anything on the Ethernet interface. If you put an IPv6 on Ethernet interface, we call it as dual stack. Now I'm going to tunnel 0. Tunnel IPv6 address. I don't want this. That's it. It's a 0th subnet. So tunnel also has got an IPv6 address only. There is no IPv4 address. Tunnel mode IPv6 624 tunnel. IPv6IP 6 mode okay, IPv6IP 624 tunnel. Tunnel sources the address, your public IP address, or you can also say Ethernet 00. And there is no tunnel destination, because destination we don't know. It depends on whom you ping. The destination of the tunnel will vary. That's all. Now, show IP interface brief. You don't have any IP address on loopback, IPv4 address on loopback or tunnel. That's why I cannot call this as dual stack. But I have it here. Whereas the Ethernet 00 is blank. This cannot be dual stack. Now, we got the tunnel ready. We got the LAN ready, means the departments ready on site 1. Likewise, I'm going to bring up site 2. Site 2, interface loopback 1, IPv6 address to 2024 colon 7C7C colon 7C02 colon 1:1/64. Loopback 2, just change the subnet. And then interface tunnel 0, IPv6 address is this 0 subnet. And show IPv6 interface brief. What is next? Site 3.
Site 3.
Okay. So here, yeah.
So IPv6 address, right?
IPv6 address. Tunnel mode is IPv6 IP 624 tunnel. And then tunnel source is Ethernet 00, my own exit interface. No tunnel destination. I need to do this on site 2 also. Tunnel mode is IPv6 IP 624 tunnel. No tunnel destination. Tunnel source is Ethernet 00. That is all. Now if you see, R4 has got no idea about IPv6. I'll show you once. Show IPv6 interface brief. No IPv6. Show IPv6 route. No routing table. But when you go and ping from here, okay, first of all, we need to say IPv6 unicast routing because you need IPv6 support in this router. Routing won't happen. No, pinging it will ping only the next stop. The routing won't
So
happen.
if I
What is
don't give
routing?
IPv6
Traffic
unicast
is
routing, it won't
going
ping, right?
via a router.
Routing will not
Router
happen,
is
or
used
it...
as a transit. I'm on site 3. Why did I come
Okay.
to site 3? Can someone help me? Where did we left? Okay. IPv6 unicast. That's it. Now let us go to router 1 and
Sorry.
try to ping
Yeah,
the tunnel
IPv6 unicast
interface
routing
address
is
of the
enabled
other
on all the
sites.
routers.
It will ping. Ping 2024 colon 7C colon 7C02 colon 1. You know what happened when I hit enter? This
7C02
no, I'm pinging tunnel interface.
colon 1.
I'm pinging what? Tunnel interface. Now,
No, colon 1
what
colon
happens,
1.
really? This
Colon
algorithm
1
that you
and
enabled on the
colon 1.
tunnel interface,
Oh, okay.
this algorithm will pick this portion. Only from here it can copy. That's why you should put in the second and third exit. It copies and converts into binary and derives the destination to 124, 124, 124. This is 124, right? This is 124. You are pinging from site 1. Site 1 router knows which site to go, which destination to go from the address that you ping.
Yeah.
You see?
Yeah.
What is that? Okay. The reason why it is not pinging is you need to write one static route. IPv6 route. Any IPv6 the destination that you don't know, send it via tunnel 0. This you have to put it on all the routers. That is called default route in IPv6. Why we didn't learn static and default route? We learned. We forgot.
Is that static
Now,
route? I mean,
it's called default route.
IPv6.
Now you see the ping goes. How quick, not even a single packet. This middle router has got no IPv6, but still the packet can reach the other end. Now ping the site 3. Site 3, 2024 colon 8686 colon 8603 colon I think I gave 3. Maybe I gave 1. I have given 1. That's why it's not pinging. Let me ping 1. It will ping. You see, it pings. So not only this, you can also ping the loopback of site 3. Let us ping loopback of site 3. You see, colon 1 colon. Am I right, Pala? Sam? See, it's pinging. It's pinging the inside network. Right?
Yeah.
So this is one of the migration strategy that I'm seeing people
Yes, sir.
using. in the real world. When ISP is not supporting IPv6, you can use this IPv4 support that ISP gives you to have reachability between the IPv6 site. Listen